Who are you?
I'm Robin Winsor. I'm the president and CEO of Cybera. Cybera is a not-for-profit NGO. We're based in Western Canada, and our mission is to spur and support innovation as an economic driver for the province of Alberta through the use of cyber infrastructure.
And can you explain some of that cyber infrastructure that you're managing and what you're going to be doing in the future?
We do three main areas. We run the supercomputer infrastructure, which from everywhere from Winnepeg, Manitoba, through to Victoria, BC. We run the high-speed research and education and innovation networks, and we do a lot of Web 2.0 development. So portals for things like space science, all the way through to engineering type applications. So from big science projects through to stuff for small startups.
Tell me a little bit about the supercomputer infrastructure that you guys have.
There was a move some years ago to actually grid enable all the supercomputers at the universities. They're pretty much all at the universities. So that if a researcher's got a project that fits better at some university other than his home university, he can get time on that machine. And then likewise, somebody else might have time on another machine. The job goes where it fits because we can move those around. The only problem with that is there's never enough capacity. The researchers always want more. So as Cybera tries to expand our offerings and engage business and become more of an economic driver, I can tell you, if you're an engineer, about great things you can do with a supercomputer, and you say, that's terrific. Can I get you time on the machine? No. If you're not a researcher, I really can't. And that's not a criticism of that system, it's just because it's great for the researchers, and if you're partnered with one, you maybe get a little time. But as a straight entrepreneur, hard to do. So part of what we're doing is building our own microclusters to give supercompute capabilities that we can pass out to entrepreneurs. We're using cloud technology in a couple of different ways. At the high-performance compute side, we're trying to find ways to get more of a compute on demand within the high-performance computing side. But on the other side, we're trying to get some high availability for widespread distributed computing. Ultimately, we think that there's a role for governments to play in terms of providing compute to the citizens, just as in the 20th century, you would have had people, your government providing for you security, defense, health, transportation. They build the roads, they put in the sewers. In the 21st century, compute is part of our lives. So we feel that in this century, people should have compute on demand just basically as a right of citizenship. So we're looking at, can we build clouds that would serve all 4 million people in our province?
And how are you doing that? What kinds of technologies are you betting on?
Well, we're getting our feet wet building a lot of technologies. Initially, we started out doing some of our pilot clouds for projects around things like space science and so on. Initially building with eucalyptus. And our development team found that nice idea, some real implementation problems. We're just switching over to OpenStack, and that's actually taken us to dealing with Rackspace recently.
Very cool. What caught your eye about OpenStack?
Well, the support picture is a big part of it. The fact that we can get the support that we really need from a very reliable organization, that helps a lot. Open source is terrific. Open source with support around it is that much more compelling. There's also the emphasis that we need on IP version 6. IPv6 simply wasn't going to happen for us under Eucalyptus. With OpenStack, we can make that happen properly. And IPv6, we all know the addresses are gone.
Yep.
In Canada, I'm not sure about the situation in the States, but in Canada, we have a few telcos who really control communications, the whole ISP market, and with IPv4 addresses exhausted and people not ready on IPv6, effectively all the small ISPs are locked out. If you want to start a small ISP tomorrow, what are you going to give people for addresses? Yeah. You're going to give them IPv6? I tried having my staff cut off my IPv4 stack and go IPv6 only for, I was going to write a blog about it.
Yeah. What are you doing with the radio telescope? Tell me about that project.
That's an interesting project. There's a project that actually got started in Canada with a professor named Russ Taylor at the University of Calgary to build the world's largest radio telescope. It's going to be 100 times bigger than anything that exists today. And when that one comes on stream, the data is going to be a petabyte per second. The telescope itself is going to be built either in Western Australia or in South Africa. There's a pilot one going in both of those sites. It's a 1% model, but 1% of something that's 100 times bigger is, of course, state-of-the-art. Yep. So we'll learn a lot about the actual structuring of the telescope and the data. It's going to be an amazing thing. It's going to tell us things about the universe and open up research on dark matter and all sorts of things. Just as when the Hubble was first launched, we learned all sorts of new things. The data, however, is a huge block, and we're going to have to figure out how to handle it. Right now, we don't know, and that's part of what we're doing. We have 8 years before that telescope comes on stream. So we have a little bit of time, but we can't just rely on Moore's Law and all that sort of stuff to get us through, because we need some big leaps.
I was out at CERN and met with the guys who built the computing system there. That thing spits a lot of data off, but they do a lot of filtering. Even in the sensors, they do filtering before the data gets put on the internet out to, I think you're one of the places where it shoves a lot of data,
yep.
right?
Yeah, our network carries that traffic coming from the Large Hadron Collider. And we got real busy again on the network after it came back on stream last September, I guess, after the accident, which was very unfortunate, but there you go, things happen. But you're right, the Large Hadron Collider, when they run an experiment, a lot of that's getting filtered right at the Atlas detectors, interesting events versus uninteresting events and running through. With the square kilometer array, there's no filtering that data. You don't know what might be there. And it's a really, really interesting project. The data flow is fascinating. Figuring out how to actually work with the data is fascinating too. It's an example of a class of problem which we call very big data problems. Yep. And there's lots of them. Square kilometer array is just one case in point. There's stuff in genomics and metabolomics, and brain imaging, you name it. All these fields are getting to be very large.
Not only that, the self-driving car is capturing, a lot of data as it drives down and it's going to shove that stuff somewhere, right?
It's the nature of the world. We're getting more and more data from all these sensors. So how do you know what you don't know about that data set? And what I see is that we're going to need to become experts in the field of very big data. The folks on the Square Kilometer Array project want government to fund that one. The folks in genomics want people to fund that one. Ultimately, what I'm saying is, let's see if we can't fund the establishment of centers for excellence around very big data so that all of those problems end up within our backyard. Part of building a public utility cloud is part of that. If we can build a public utility cloud to serve millions of people, the difference between the base and the peak can be allocated to research if it's in the same area. And so one feeds off the other. Ultimately, we don't know the questions to ask. Like on the Square Kilometer Array, will you think to ask about how does the spin rate of that pulsar relate to the chemical composition of that nearby nebula? What we're going to need to do is develop artificial intelligence agents that can immerse themselves in the data and hand out the interesting leads to the researcher. People with strong muscles found out during the Industrial Revolution that they no longer had more power than the machines. The machines did the work for them. They had to learn a new relationship to the machines. The professors of various learned fields, you're going to have to start realizing that the machines are going to dive into data and give the interesting leads. Maybe they're the professors now, and the prof becomes the grad student. Follow up this interesting lead. Wow. It's a reversal of roles. It's probably not a very popular thought if you happen to be a tenured prof, but you know what? We all get used to a changing world, and it's exciting.
Yeah. What about the infrastructure is going to need to change to deal with this world of a petabyte every second? Is OpenStack up to it? And if not, what's going to need to change about OpenStack as it goes forward?
I don't know if OpenStack's up to it, but I have a team that's ready to start working with Rackspace folks up in Edmonton tomorrow, and they're going to be learning more and more, and we're going to research. We're going to start small and build out as fast as we can, and where things break, we'll have good partners to work with to figure out how to solve those problems.
Very cool. Where do I follow your work? Is it on the web somewhere?
Absolutely, Cybera.ca. There is another firm called Cybera within the States who are Cybera.com, so we're Cybera.ca, and we post everything there, or Robin Winsor on Twitter.
Very cool. Thank you so much.
Thank you.